Hello and welcome. It is day 2 of my mission to learn Python, and let me just start by saying, wow, I was quite excited about this yesterday. A couple of things happened since then. One, just the response, amazing. I just looked, my video from yesterday got 1,000 views in its first 24 hours, and I don't mind telling you that has never happened to one of my videos before. So great to see that other people are as excited about this as I am. But second of all, I spent a bunch of time reading last night. I'm going to kind of give you the highlights of my journey. Um, and I feel like that moment in the Matrix when Neo comes out of the simulation, opens his eyes, and is like, oh, I know Kung Fu. It's just, it's starting to get good. Even sooner than, I mean, I knew it would, but even sooner than I was expecting. So that's awesome. One thing that's just worth addressing, I haven't got a lot of this directly, but I've seen this come up a lot when people start exploring the things you can do in Python in Excel, and typically start with things that look like what you would do in Excel. Lots of comments saying, well, why wouldn't you just do it in Excel? It's much easier. So I've been as guilty of this as anyone, but there's a saying that when you have a hammer, everything looks like a nail, and when you have a hammer that is as flexible and versatile as Excel, certainly it makes a lot of things look like nails. But Python is a totally different toolkit. I need to learn a little bit more before I actually have a sense of which things Python is better for versus Excel. But even just from what I've done so far, I've already realized that some projects that I, abandoned or kind of didn't push as far as I could because they were hitting the kind of speed and computation limits of Excel are probably going to become accessible now that I'm using Python, just because it's so much faster. Also, just the availability of, bajillions of built-in and shared libraries. Like, there's lots of people have shared great videos already about the amazing custom visuals you can make, that kind of thing. There's a lot of potential, even if you're doing things that are basically still Excel things, but through Python. And then there's a whole other frontier of things that are just not Excel things at all. So that's just to address the kind of, why aren't you just sticking in Excel question. Like I said, I haven't had a lot of people ask me that directly, but I've seen a lot of people asking others that question. So today is going to be a high-speed tour because, wow, like I said, I know Kung Fu now. I feel like I learned a lot last night while I was reading. So I'm going to do sort of try and roughly follow with some of the bumps smoothed out so that you don't spend as much time stuck behind basic obstacles as I do, but roughly follow the path of what I tried to figure out and what that ended up teaching me yesterday, which is going to be most of the video. And then if I have time at the end and if the video hasn't gotten too long, I'm going to do one sort of challenge, unscripted, that I have not prepared for, that I have a kind of loose sense of how to approach, but I haven't done any of the Googling for syntax or anything, and you can watch me flail around with that. So let's start with, this is where we left off yesterday, was this Excel BI challenge, checking, for these various strings, are they lowercase, start case, all caps, sentence case, or mixed case? And on the file that is saved down in the shared drive, I've added a list comprehension version. I'll talk more about list comprehension later. I'm not going to get into that on this file because I'll talk about it in other ones today. But what I was trying to do yesterday was use map. So I wanted to map this function classify onto this range. And I couldn't figure out why I was going wrong, and I had actually given up on it, and then I came across Bo having posted this, that you could use apply, which was great. I used apply, it worked, all smiles. But I still wanted to try to figure out what was going wrong with map because, as far as I could see, apply, you could just apply to one column, which is great if you want to transform one column, but one of the nice things about map is you can provide it with multiple arrays. So in other words, if I map 4 arrays, each with 10 objects, then I can apply a function that takes 4 arguments, and it'll take, take those 4 at a time and apply the function to them, which maybe there's an equivalent of that with apply, I don't know, but I couldn't think of it, so I wanted to try to get map to work. So that's where I started off. And related to that, I had this kind of thought, well, I'm pretty sure that Python has not just map, but also scan and reduce. And I kind of know those from Excel. And so maybe that's a natural place to start looking for some more advanced Python. And then I spent some time Googling, like, I Googled something like, Python map lambda examples, and came across some interesting stuff, but also a lot of kind of finger wagging of people basically saying, you can do that in Python, but it's not very Pythonic. Find better ways to do it. Let me see. So first thing, let me switch to this one. This is an esports problem. I made a video about it actually at the start of this week. It's only 2 days ago, believe it or not. It's been a lot of Python since then. Just as the most recent example I could think of where I would want to apply, like map a function to, here's a column of speeds, a column of turning speeds, a column of power-up boosts. And I wrote a function. I won't go through the logic of this function because this is basically almost line for line the exact function that I wrote as an Excel function with let, just defining each step by reference to the previous steps. So if you're interested in the specific problem, go look at that video. But the key thing is we have a car racing around a track, and the time it takes to get around the track is a function of its speed, its turning speed, how much of a power up it gets when it hits a power up square, and whether it's a pit lap or not. And so I wanted to be able to apply that to these. There were no pit laps on this one, so I just used an empty column as all zeros for whether it's a pit lap or not. So in the same kind of spirit as what I had tried unsuccessfully yesterday, I tried map lap time against these 4 columns. That gave me something called map, so it didn't totally throw an error. But when I tried to return it to the grid, that failed. So it turns out I was actually doing 2 things wrong here. So one is that map in Excel applies the function to all the different arrays and gives you the answer. Map in Python kind of queues that up, but doesn't actually do it. And I didn't initially understand why you would ever want to do that, but I read a little more about it later. The idea is that you might want to iterate through your map, but stop at some point, like there might be some breaking condition. And so you want to have the ability to kind of lay out the map, but not calculate every single cell in it, because you might not need every single cell in it. So it's a kind of actually pretty cool computational efficiency thing. So that's the first thing, is to get it to return a list, you need to wrap it in list, which you can do like wrap the cell that returns the map in list, or just wrap list directly around map. So that's the first thing I got wrong. And the second thing is I was thinking of this as, well, I'm pointing to this Excel range, and so that is just an array in Python. But of course, because Python in Excel is set up to think about data frames, this is not just giving me an array, it's giving me a data frame with a single column, and that's not quite the same thing. If you've used Power Query, this concept will be somewhat familiar to you. That think of a table is a collection of columns. A column is a header with a list of values. And so from a table, you can project out a single column, or you can project out the list of values in that column. But what we have here is more like a table than a column, and you can't apply map to a table. So it's one of these things that, once you know, the fix is very easy. So here's the fix. Slightly different way here. So here I did it by defining a data frame. So I defined the data frame of the whole thing, gave the column names just to be easy to refer to, and then I used that down here. So here I'm saying, dataframe.sp is giving me the list of values in the speed column, as opposed to giving me a table with one column. That's a bit of a subtle difference. The other kind of way that you can do it is you can say, like without even naming columns here, you can say, give me column 1 from each of these. And that will also, if I've done it right, risk of doing anything live, but that should also give me all the values back. So that'll spin for a second, and then we'll Control-Alt-Shift-M to get it to spell out. Here we go. So that works. So the inputs to map basically either have to be a range square bracket 0 to give me kind of the list of values in that range, or you need to use the data frame and then extract a column from that. So that gives you the map, but I also wanted to round this, and it turns out, unless I write a new function for lap time, for like rounded lap time, then that's a little harder to do. I could write a lambda in there, but it's a little convoluted. The other thing is, because of the way map works, I had to give it a range of zeros, because I wanted the last argument to be 0. So it turns out the list comprehension approach to doing the same thing in Python is actually a much nicer approach. So let's pause there, jump over to my other workbook, and talk a little bit about what is list comprehension in Python. So a few examples. here is test1 just generates a range of the numbers. Now, range 10, Python is all 0 index, so range 10 is the numbers 0 to 9, not 1 to 10. That takes a bit of getting used to if you're used to Excel, but it's also the case in Power Query and some other languages, so it's not that crazy. So what does list comprehension mean? It means we can do something for all the values in test. It's a lot like in VBA, you can say for each, C in collection. Is there an equivalent in Power Query? I can't think. Anyway, so here's what the syntax looks like. So this is just echoing back the list. You're saying I for I in test1. So iterate. The key thing is that this has to be an iterable, which is not just a list in Python. I'll talk about text in a minute. Like a text string isn't iterable. Lists are iterables, tuples, I'm pretty sure are iterables. Lots of things are iterable in Python, which means you can iterate over them. So for I in test1, just give me I. And that just echoes back the list. But then you can also, instead of just saying I here, you can apply functions here. So here is a function 3 times I plus 4 for I in test1. Pretty cool. Incidentally, just one of those little like Excel stumbles, when I was first testing this, I said I squared for I in test1 and got, when it's ready, got these very funky values. That's because caret in Python is, I think, a bitwise XOR operator. So this thing, like times is exponentiation operator in Python. So that's just something to be aware of. The other cool thing about list comprehension is that you can filter it. So instead of just saying, give me, compared to this one, I for I in test1, you can say I for I in test1 if this is saying I mod 2 is equal to 0. In other words, if I is even. So this is give me all the even values. But this here can be a much more complex function. This here can be a much more complex function. So that's the very basic idea of list comprehension. Like I said, a string, here's just test2 is the string hello world. A string is also an iterable in Python. So here's I for I in test2. If you've been using dynamic arrays in Excel and you're used to using equals mid word sequence len word 1 to split out a word into characters, this is just beautifully simple. Then you can again apply a basic function to that. So like here's put hello in front of each one of these. You can apply a filter and a function. So here I'm just filtering out the space. So I'm only saying hello to actual letters. And again, syntax difference. It's not that for not equal, it's exclamation mark equal. That's a fairly common thing in other programming languages as well. And then one other thing, just a kind of cool thing for iterables is there's a thing called enumerate. So instead of iterating over test2, I can iterate over enumerate test2. And then instead of saying for I in that, I say so enumerate basically gives the list of numbers of the kind of index positions and then the list of values in the iterable. So n is assigned to the number and I is assigned to the value of the iterable. So here we're saying give me the letter I if the position number, again 0 based, is 0, 6, or 7. And that gives me HWO, which is H in position 0, W in position 6, O in position 7. Again, much more powerful things that you can do with enumerate than that, but that's just to give you an idea of the syntax. Last thing I want to talk about is zip, because zip is pretty important to being able to apply this as a kind of map replacement. So here's just a general example of what is zip. So if you have one list and then another list, if you've used Power Query, list.zip in Power Query does exactly the same thing. It takes any number of lists of the same length. I don't remember exactly how it behaves if they're not the same length, but we'll ignore that for now. And it zips them together. So if you have, let's say you have 5 lists, each of 100 items, then what you get is one list of 100 lists of 5 items. And that's basically what zip does as well. So let's just print this. And I think it'll pop up. Yes, it will pop up. So that when you print, it goes over to the diagnostics thing. Oh, sorry. So I guess I do need to wrap it in zip in list before I print it. There are some nuances around things that need to be wrapped in list or not before you work with them. But let's try that again. Yes, there we go. So now you can see it's made one list, which is the square brackets, and each item in the list is a tuple. I won't get into the subtleties, but a tuple is like a list, but not exactly the same as a list. A tuple, which is, so the first tuple is the first item from each list, the second tuple is the second item from each list, and so on. So here is a basic list comprehension for a zip. So again, just like with enumerate, you can assign two values. So the zip, and again, you don't need to wrap it in a list because it's kind of smart about how to enumerate this. So the zip has 3 pairs of values, and you assign each of those pairs of values as you go along the value AB. So then this is saying a squared plus 4b for A in the first list and B in the second list. So pretty cool. And then just another kind of random example here, just using references from the earlier ones. So again, here I'm just saying I want certain positions from here. So I'm saying A for AB in zip these two things, and again, to reference them like this, you have to put the square bracket 0. So zip the two together, take A where B, which is this whatever square of the index position, is greater than 19, and you get the last 5. So list comprehension, very cool. So now let's go back and look at this, at the races, through the lens of list comprehension. So I wrote this a few different ways. Here's the most basic. So again, this is the equivalent of the I. This is like some function of the 3 variables for those 3 variables in this zip. So in this case, the function is lap time of this speed, this turning speed, this power up, and no pits. And the nice thing about this, as compared to map, is that I can now just apply round here. I don't know why there are underscores around round, but whatever. Just, it is what it is. Google for syntax. And then we take speed, turning speed, and power up from zip these 3 things together by that 0. Second way to do this is using the data frame that I defined earlier. So, reference this whole block as your data frame. These are your column names. Then you can just zip the 3 columns that you want together and then apply lap time to them in the exact same way. Or the other thing that's pretty cool, if you want to apply it to several columns that are all just next to each other, I Googled like how do you turn a data frame into a list of lists and came up with this cool syntax. So here, without any data frame defined in advance and with only one reference to the whole table, you can say XL of that table dot values, which turns it into like an ND array type n-dimensional array, and then dot to list, and that creates a list of lists of these rows, just exactly like zipping the 3 columns together. But this one scales nicely. Like if you had 100 columns, you wouldn't need to have a formula that had 100 references or 100 header names or anything like that. So that's pretty cool. So that's how you apply lap time to that. So that's the kind of hello list comprehension. Now let's go and look at the largest substring. So this was the next Excel BI challenge that came out last night. So I tackled this having gone through the journey that I've just described to you of learning about list comprehension. So the challenge is cut all the substrings from column A of the length given in column B and find the max. So for example, for that example is not in here, but anyway, for number 80988 and length equals 2, the substrings are 80, 9, 98, and 88. So the maximum is, that looks like a typo. I think the maximum is 98, not 88. But anyway, so here, let's look at this one. So here, your substrings are 78, 82, 25, and 55. And so your maximum is 82. So that's the answer expected. So first thing, when I was doing yesterday's challenge badly, so over here, so the neat way that I found later was to use dot capitalize to find capitalized case. But before I discovered that function, I did it my own clumsy way, which was take the first character and make it uppercase, and take the rest of it and make it lowercase. So that gave me a little bit of exposure to these slices. And this, again, I think is a thing that it's a syntax that you would apply to a list as well, but in some sense, a string is like a list of characters in Python. I'm sure there's more nuance to that I'll discover later. So here I just played around a bit exploring slices. So Here is, well, let's just start with the basics. So if I go 1:1, that gives me nothing, and that would have thrown me for a loop, but now I actually get it. If I go 1:3, again, remember that we're 0 based, so 1 is the second character, and so 1:3 I gradually figured out means start at 1, which I would think of as 2, and go to the one just before 3, which I would think of as 4. So in other words, here you go, this is character 1, this is character 3, so when you ask it for from 1 up to just before 3, it gives you 82. If you omit one of these, it goes, I think, all the way to the end. Yes, so that's 8255. If you omit the other one, let's say up to 4, that gives you the start of it. But what I was interested in was, okay, let's say I'm interested in something of length 2. So let's go 0 to 2. That would give me a slice of that, and equally 1 to 3 would give me a slice of that. And so now, with my list comprehension hat on, I would say x, let's just start simple, x plus 2, for x in range, I think, len of this. Close, close, and then close square bracket. I think that'll work. Let's see, that should give me a list of, yes. So now that it's falling off at the end because it's trying to get a list of 2 characters starting from the last character, which doesn't work. Well, anyway, that's kind of as much setup as you need. So let's go and look at the list comprehension solution, and I'll kind of explain it piece by piece. So first, let's focus on this piece here. So this is exactly what we started with. I've just defined num to be the number, and leng to be the length. So here, for example, num is 78255 and leng is 2. So I go from 0 plus x to leng plus x for x in the range up to the length of the number minus the length we're looking for plus 1. And that's just, so here, for example, if I'm looking for strings of length 2 from a string of length 5, then I want to consider 4 different starting positions, starting position 1, 2, 3, and 4, because I can't start from position 5. So this one just avoids having the hanger-on that's shorter than the rest. So that gives me all of the slices that I can get from a given number for a given length. Then I take the max of those. Now, maybe I should have swapped the order of int and max here, because I should be converting them into numbers before taking the max. When the numbers are all the same length, taking the biggest text version of the number and taking the biggest number are actually the same thing. If they're not the same length, then I don't know how that would behave. So in other words, if I have, let's say, 9 and 84, and then if I have that times 1, that times 1, by normal Excel sorting, these would be, because it's kind of alphabet-based sorting, so you sort on the first character first. 8 is less than 9, so sorting text and sorting numbers would give you different orders. But if the numbers are the same length, it doesn't make any difference. So I think probably it would have been a little smarter to put the int inside. So in other words, int takes the text numbers and converts them into numbers, a little bit like multiplying by 1 or whatever in Excel. Then you take the max of those. So that, everything up to here, gives you the answer for one given input of num and leng. And then I just want to do that for num and leng in the list of lists. So this is the same kind of handy syntax to just say, take this table, convert it to values, then give me a list of lists. So you get one list that's 78255, one list that's 9999153, and so on down. And then you just calculate that solution for each one of those, and it dumps the whole thing out. Very, very cool, and kind of relatively simple once you get the kind of mechanics of list comprehension. So that was the first challenge, and then there's a new entrant in the world of daily Excel challenges on LinkedIn, which is this guy called Cameron Mumtaz, he's up to number 40 now, actually. He's been knocking around for a while. But he does daily challenges. I would say probably slightly less complicated than the Excel BI ones, but not much. I don't know. It varies. But anyway, so here's the challenge. You have a SKU number that has a brand code in the middle of it, and you have a quantity. So you want to extract the brand code from the SKU number, make a unique list of brand codes with their total quantities. So this is one. This was actually relatively quick for me. I probably got this done in under 10 minutes, I would think, because I had seen Owen Price do basically the two things that you need to do to solve this question in another video. So the first thing you need to do is extract the code here. Now, as it happens, the first set of digits was always 4 here, but let's just make life a little harder for ourselves and make some of them shorter or longer or both. Jump down here, make one of them longer, because Python can handle that. So the trick here is a thing called regex extract. And so the idea is the most basic piece of regex, if you're familiar with wildcards in Excel, you'll already have some idea of. So like, for example, the format here is something like some stuff, and star is a wildcard for any characters, followed by a dash, followed by some stuff, followed by a dash, followed by some stuff. That's the format. And as a validation, for example, you could say countif this list in that format or not in that format to see are they all in the desired format. But what you can't do is, basically what we want to say is, given this format, I would like to get this piece out of it. And that is exactly what a regex extract in Python can do. It's super cool. It can also match much more general patterns and other things, but let's start with the basics. So equals py. Then I'm just going to say df equals, actually I probably used df in this other one over here, so let's define a different name. Let's go input equals this table. And then I want to say input. So first I'm going to add a new column. So call it brand code. And that's going to be input SKU space number. Well, first let's just make it input SKU space number, and then let's return input and have a quick input, and have a quick look at it. It's not feeling very hurried today, but that's okay. Whoops, close me out of that. Why? Don't know. Still busy. Slightly surprised it's taking that long, but never mind. Oh, sorry. Here we are. Here's our data frame. Okay. So, why is it still jumping around? All right. Something has it very wound up. Anyway, okay. So here's our data frame. We've got a new column added called brand code. Simple, very easy to add a new column. So now, what I want is to take, and this again, the syntax, I just went back to Owen's video and looked at it, but you can also just Google. Let's see if I can remember it now because I wrote this last night. So string.extract, and then is the R inside, so R for regex, or I think it's for regex. Anyway, so the pattern, I mentioned it was star dash star dash star. In Python, obviously the format is different, so period, or a full stop to my friends on the other side of the Atlantic, as I once was, is any character, and some kind of token followed by a plus means that some number of times, followed by a dash, followed by some number of characters, followed by a dash, followed by some number of characters. We can also distinguish, numbers versus letters versus lots of other special characters and things, but I don't need to do any of that. The important thing is that I'm telling it I want to capture this. So this is called I think it's called a capture group. So it's just saying, give me, so there's some stuff followed by a dash, followed by some stuff that I want, followed by a dash, followed by some stuff. If I got the syntax right first time, I'll be pretty happy, but let's see. I didn't. All right, so let's just go check the here's one I made earlier. Okay, the R is outside the quotes. That kind of makes sense, actually. Why would the R be inside the quotes? Because it's some kind of operator or something. Anyway, okay. So now, does that behave better? Yes. So now I've got my brands, and then it was just dot group by. I want to group by brand code, and I'm interested in what is the thing I'm interested in? Not the Q number. I'm interested in QTY period, and I want to dot sum. And again, if I get that syntax right the first time, I'll be pretty happy because I haven't done this a lot, but yes, it works. Hooray. So that's basically what I wrote over here. I actually manually applied names to these columns because then you can refer to them. If the name has no space and no special characters, you can just say data frame dot column name. Otherwise, you have to do this thing like data frame square brackets, quotes, column name. So this is just a little easier. But the core piece is exactly the same. So you take the skew, take the string of that, extract using regex for just this piece, and then some. A couple of weird things here. One is the way it outputs this is as a series, so I can't get it to put a label on this column. I'm sure there's a way to do that. I haven't spent much time trying to figure it out. The second thing is these, for some odd reason, I tried to format them as numbers, but they are not numbers, which is kind of weird. And I can test that with isNumber, and it's false. Why is it not a number? I don't know. I tried a couple of things here. I tried adding this line to map the int function that would, if this had been taken as text, it would turn it into a number. Didn't change anything. I also found some code somewhere that was supposed to format this as a number. That didn't work. So I don't know. Again, as you might expect at this stage in my learning journey, lots of who knows what's going on here. But anyway, the main piece is we wanted to summarize by brand code, and we were able to do that. So hooray. Oh, interesting. I guess this is naturally sorted, and this kept them in the order they appeared in here. So that's another thing that's interesting. I'm sure there's a way to change that, but not what I'm doing right now. So anyway, that's sort of the end of the pre-scripted piece. Last thing, I'm going to try and do this live, is today's out-of-the-box challenge, also by Camran. And this is an interesting one. So we're given a starting year and month and an ending year and month, and we want to sum all the numbers between those two. So you can see it's kind of highlighted the range here. So this is what we're interested in summing, but we need it to be dynamic. So like I said, I have some thoughts on how I would structure this, because how would I structure it if it were an Excel thing? That's something I understand, but I have no idea how the syntax is going to work. If it takes me more than 10 minutes, then I'll just give up and I'll save the file down in the usual folder with the solution in it, and you can go and look at it later. But let's give it a go. So the first thing I'm going to want to do is unpivot this, because I think what I want is just to have this in all one big column. And then what I want to do is either convert the combination of year and month to a date. That seems kind of harder, or just convert the month to a month number by some kind of list match, and then just have 2019.01 be January 2019, 2019.02 be February, and so on. And then I should be able to filter for between 2020.06 and 2022.09, and then sum that. That's the idea. Let's see how it goes. So first thing, we'll go equal py. So I want input equals this, and now I'm just going to try winging it. Can I just unpivot? I probably need to tell it what to unpivot on, don't I? So let's just try saying unpivot on month. Don't know, that seems like it might work, but I won't be at all surprised if it throws an error, and if it does, I'll go Google for some syntax. There's no attribute called unpivot. Okay, so let's go over here. Let's go unpivot data frame Python pandas. Sure. Unstack. Okay, let's try unstack. And it seems to have no arguments. I guess maybe that means it presumes it unstacks everything except the first one. So let's just try that. Input.unstack. No, we didn't like that. All the input array dimensions for the concatenation axis must match exactly belong dimension 1. Okay. I guess I need to read a little bit more. Why are you jumping around on me? Oh, I just saw the word melt there. I have a feeling I do remember seeing melt in one of Owen's videos. Let's try looking at melt. Obviously, this part is considerably less fast moving because I have no idea what I'm doing, but you know, that's part of the fun. So melt the data frame on ID variables and value variables. Okay. I'm just going to start with pd.melt on the data frame and see what that does, and then we'll try adding more detail. So pd.melt input. Okay, that gives me a data frame at least. Yeah. Wait, no, that. What? Oh, okay, right, because I guess I don't have. So this is like melting the entire thing. I need to have it keep one ID column, which I think I have the syntax for here. So ID vars equals that. Okay. So, oops, right. Let's come back over here. So, comma ID vars equals month. That work? Yes! Beautiful. Absolutely beautiful. So let's output that to the grid so I can admire it in all its splendor. Okay, so now I need to figure out how do I match something against a list position. Or do I want to try and figure out how to convert a text month to a... Let's try and do that. Let's convert text date to date in Python. I keep writing Python with a G at the end. I have no idea why. Strip time. Oh, yeah, this could work. This could work. So, all right. So, all right, I need to give this a name, I guess. So I'll call this unpiv. So then, let's just look at the syntax. Datetime.striptime. Oh, hang on. I need to import datetime. Okay. So just put that up. I guess I'll put it here. So equals py. Import datetime. Okay. So now let's see if we can do it. So now we name this unpiv, and then we say and new line. Oops, sorry. No, I'm used to control enter and enter getting mixed up. But anyway, so unpiv date equals. So why is this covered up? There we go. Datetime.striptime. So I think I want. I don't know if I can use list comprehension here. Ooh, okay. All right, let's try this. Unpiv month. Let's just start with this. Unpiv variable. Nope, we didn't like that. Can only concatenate str, not int to str. Okay, I didn't think either of them. Oh, okay, fine. So can I dot str? Is that a thing? It is not. Okay, so now I need to convert int to string Python. Oh, okay, so maybe if I just wrap it in str instead of saying dot str. Let's see if that works. None. Oh, what? Oh, wait. Hang on. Maybe because I need to now return unpiv. Maybe this is working? Let's see. Okay, what the heck is going on here? Huh? Ah, okay. That's giving the string of the entire column. Okay. Let's see. I don't know if syntactically I can do this, but let's try doing this in list comprehension land. So let's just start with A plus strip B for A, B, C in unpiv.values.toList. Yeah, let's see if that works. Yes! Hooray! Okay, so now I can do better. So now the format that I wanted for that strip, pretty cool function here. Datetime.striptime. Now I don't, oh yeah, I think it looks like maybe, I don't know. A lot of experimenting to do here. So let's go datetime.striptime. So it's going to be strip B plus dash plus A plus dash 01. And I assume this is the format, so let's make that M. Let's see. Let's see. Nope, didn't like that. Does not match the format. Why? Okay, so strip time. Let's just try searching for datetime.striptime text month. This is just, in case you thought I was clever because I zipped through all those things that I did yesterday really fast. Oh, interesting. Okay, so A, D, B. I guess this is B. Weird. All right, let's try B. I probably need to read this a little more carefully, but let's just try it. B would be a funny abbreviation for month, but maybe, yeah! Amazing! Okay. Cool. Okay. So now I just lol. I just need to get my bounds. So I'll say lbound equals datetime.striptime. I just take all of this, I guess, and then we'll change the inputs. So string of this plus all that stuff plus this. Let's see if that works. Let's return lbound. And if that works, then I'm basically done, and I just need to figure out how to filter. So this is, it's actually working. Love it. Why did it keeps flipping me between workbooks for some reason? Not sure why, but anyway. It's a beta test, so you can't really complain if some things don't work exactly like you'd like them to. All right, so that's lbound. Let's get ubound. And we just need to move these references down. So this is rows 12 and 13. So J12, nope, J11 and 12. Okay, so then I'm interested in, so I just need to, filter data frame. I've seen how to do this, but I can't remember the syntax. Filter data frame by column value, yes please. Column name equals column name gray, yes, here we are. Combine multiple conditions with and df.lock. Okay, let's try this. Yeah, wrong one. Lots of files open. All right, last one. Okay, so let's try this. So it's not df, it's unpiv.lock unpiv. And it's not column name, it's date. And actually, because the name has no spaces, I can just call it unpiv.date. Greater than or equal to lbound and unpiv.date less than or equal to U bound. And is this working? Oh my god, I think it is. Amazing! So, well, let's just see if I, oh, I guess I can't. Oh, I can't send this. 7056. Yes! That's the expected answer. So now I think I just need to project out that column and sum it. So let's just try this. I'm interested in, can I just say dot value like before? Sorry, not capital, not capital. I didn't mean it. When you work in Excel, you're used to everything being case insensitive. All right, dot value dot sum. Yeah! Okay, beautiful. I said I would stop if this took me more than 10 minutes. It actually took me 15 minutes, but you get the idea. Anyway, I am very excited about how much I have learned in 2 days of messing around with Python. As you can see, this kind of last 15 minutes is like, this is what the actual learning looks like, is lots of fumbling around, lots of Googling. I still don't understand a lot of what's going on here, but a lot of this just comes from experience. You get in your reps, you build it up, and yeah, well, that's what I've got for today. Thanks for watching, and I hope